Let's talk about how to calculate the area and perimeter of triangles, rhombuses, and trapezoids. The formulas that we're going to learn today are an adaptation of the formulas that we learned in the previous lesson for the areas of rectangles, squares, and parallelograms.
First, let's talk about the area of a triangle. The area of a triangle is equal to 1/2 base times height. And similar to what we talked about with parallelograms, the base and the height have to be perpendicular. So as you can see on the diagram that we have on the screen, the base and the height are perpendicular. I can see that because they have this little symbol for a right angle. So neither of these two side lengths of my triangle are the height. The height oftentimes will be inside of the triangle. Every now and then it'll be one of the sides if it's a right triangle. Sometimes it'll even be outside of the triangle, but the height, no matter what, has to be perpendicular to the base. You might notice that this formula looks somewhat similar to what we had with the area of a rectangle or the area of a parallelogram, that it's the base times the height, except it's only half of it. Why? Why is it only half? Well, that's because a triangle that has the same base and height as a rectangle with the same base and height is only half of that total area of the rectangle. There's actually two triangles in this rectangle that have the same area. So the green one that we talked about originally, and then if you add these two yellow parts together, it would have the same area as the green one. In general, for any rectangle, you can put a triangle inside of it, and it will be half of the rectangle's area, as long as the base and the height are equal. Now this is an example where the triangle is a right triangle, so you can easily tell the base and the height. They happen to be two sides of the triangle, but it still works even if your triangle is any other kind of triangle that fits inside of this rectangle. No matter what my triangle looks like, all of these triangles have the same base and the same height as the yellow rectangle, so the green triangle will be half of the rectangle's area. And it's actually a similar situation for the area of a rhombus. The area of a rhombus is equal to 1/2 times diagonal 1 times diagonal 2. So you need to know what these measurements inside of your rhombus are, the lengths of the diagonals. To calculate the area of a rhombus, you never use the side lengths. The side lengths don't matter here, it's just the diagonals. And that's because this rhombus is equal to half of the area of a rectangle that has the same base and height. So again, let's look at a rectangle. This area would be base times height. But if I put a rhombus inside of it, this green rhombus is half of the area of the entire yellow rectangle. In fact, if you were to take each of these yellow triangles and smush them together, you could create another rhombus that's identical to the green one. So that's why the formula for the area of a rhombus is 1/2 of the diagonals multiplied together. The diagonals are equal to the base and the height of the rectangle, but I only need half of that rectangle's area. And then the last formula I want to talk about for today is the area of a trapezoid. It is 1/2 of not just base times height, but 1/2 of base 1 plus base 2 times height. So it's kind of similar to the other formulas that we've looked at, that it has some bases and it has height and it has a half. But what's going on with adding the bases together? Well, really what you're doing here is finding the average of the bases. 1/2 of base 1 plus base 2 is the average of the lengths of the bases, and then you multiply that by the height of the trapezoid. Again, relating it back to rectangles, the area of a trapezoid is equal to the area of a rectangle whose base is the average of the two bases of the trapezoid. It's just adding up all three sides. There's not a fancy formula for perimeter of a triangle. You just add up the three sides, which is 12 and 9 and 15. So the perimeter of this triangle is 36 inches. On our next triangle example, we have a lot more measurements labeled for us, and we're actually going to use them all. First, let's calculate the area. Remember that the area is 1/2 base times height, and that the base and the height have to be perpendicular. So what I'm going to look for as I analyze this diagram is, do I have some lengths that are perpendicular? And I do. My 9 inches and my 12 inches have a little right angle symbol. That means these two are perpendicular. So this side of the triangle would be the base, and the 12 inches inside of the triangle would be the height. So you actually end up with the same answer as what we had before, even though it's a different looking triangle. It has the same base and the same height, and therefore it has the same area. However, this one will have a different perimeter, because this time we have side lengths of 9 and 12.4 and 13.5. So my total perimeter, when I add up all three of those numbers, would be 34.9. And our last triangle example shows you how it might look if your height is outside of your triangle. It's kind of rare, but it does happen that if you wanted to use 9 as your base, and I wanted to draw a line that was perpendicular from the base to the other vertex, well, it wouldn't fit inside of the triangle, so we actually have to extend this base and drop a perpendicular line from the vertex to create the height. And the base and the height are still just 9 and 12, so it's the same area as the other two triangles. Even though it's a different looking triangle, they have the same base and the same height, so they have the same area. But again, they'll have different perimeters because they have different side lengths. We still have 9 as one of our side lengths, but our other two side lengths are 12.6 and 17.7, which gives me a total perimeter of 39.3. All right, let's try some rhombuses. The area of a rhombus is equal to 1/2 times diagonal 1 times diagonal 2. And oftentimes on a rhombus, you'll see the diagonals labeled like this on the outside of the shape. And that's because of the way that the diagonals intersect each other. It can be hard to label what those diagonals actually are in a clear way. So if you see lines like this outside of your shape, that's telling you how long each diagonal is. So one of my diagonals is 9 inches. The other diagonal is 12 inches. So my area is 1/2 9 times 12. And that's the same thing as all the triangles. Again, because it's just half of a rectangle. And then the perimeter, well, remember that rhombuses have all 4 sides are the same, so even though only one of my sides is labeled as 7.5, I can assume that all 4 of my sides are 7.5, so my perimeter is a total of 36 inches. Let's check out another rhombus. This time we don't have the measurements for the diagonals outside of the rhombus. Instead, we have part of each diagonal labeled inside. So this 4.5 inches only goes from this vertex to the right angle. And same with this 6 inches, it only goes from this vertex to the right angle. So if I need the entire length of each diagonal, I need to double each of these, because if this is 4.5, then this other side of the diagonal also has to be 4.5. So this entire diagonal would measure 4.5 plus 4 would measure 9 inches. And then this vertical diagonal would measure 12 inches. Now again, you might be saying, well, wait a second, that's the same area, and that's because these are actually the same rhombus, just labeled in different ways. So the first example I showed you had the full diagonals labeled outside of the shape, but sometimes you'll see a rhombus with part of each diagonal labeled inside of the shape. So just be mindful of what it is that you're looking at so that you can set up your formulas appropriately. Now, if I want to calculate the perimeter, well, I need to know my side lengths. And in this diagram, we weren't given the side lengths. But don't we have 4 right triangles in here? And I know the legs of each of those right triangles, so I can use the Pythagorean theorem to figure out C, the hypotenuse. So I have 4.5 squared plus 6 squared equals C squared, and when I crunch those numbers, it turns out that C is 7.5, and that seems correct to me because that was the side length that we had on the first version of this rhombus, so my perimeter must be the same as before, 36 inches. Next up, we have a trapezoid. The area of a trapezoid is equal to 1/2 times base 1 plus base 2 times the height. The height has to be perpendicular to both of the bases. So in this diagram, this side right here, labeled as 12 inches, has to be the height because it's perpendicular to base 1 and to base 2. And the bases, you might remember from last chapter when we learned about trapezoids, the bases have to be parallel. So the two sides that have the same slope, that are going in the same direction like this, are the bases. So let's fill in our formula. We have area equals 1/2 times base 1 plus base 2, so that's 11 plus 7, times 12, because that's the height. And I would just type that straight into the calculator and get an answer of 108 square inches. And then for the perimeter, there's no special formula for that, you just add up all 4 of the sides, so my perimeter is 42.6 inches. So this was a relatively easy trapezoid to solve because we had all of the measurements that we needed. Let's look at a more complicated one. The good news is the area is easy to figure out on this one because we do have the bases and the height. The 12-inch dotted line inside of the trapezoid has to be the height because it's perpendicular to the bases. And then the bases are 6 and 12, so let's just fill it in. Area equals 1/2 of 6 plus 12 times 12. And when I crunch those numbers, I get 108 square inches again. And yeah, that's the same answer as what we had on the previous trapezoid because they have the same height and the average of the bases is equal. The average of 11 and 7 is 9, and the average of 6 and 12 is also 9. However, if I want to calculate the perimeter, I need to know these 2 missing side lengths. This 12 inches on this dotted line inside of the shape won't be part of my perimeter calculations because that's not one of the numbers on the outside of the shape. For perimeter, you just count the numbers on the outside, and I'm missing 2 of them. Thankfully, though, they do have congruence marks, so as long as I know one of them, I'll know both of them. So we're going to have to use the Pythagorean theorem. You probably guessed that already based off of how much we used the Pythagorean theorem in the previous lesson. So find yourself a right triangle, like this one, and let's figure out C. That would have to be the hypotenuse, right, because it's across from the right angle of this yellow right triangle. And then this side over here we could also call C, because those are going to be the same thing. But the problem is I only know one of the 3 sides of this right triangle. But let's look at the bases in relationship to this little chunk of the base. If I were to drop my other height, would you agree that this shape created in the middle is a rectangle? Because since both of these lines are perpendicular to both of these bases, I have to have all right angles, so that makes this a rectangle. And we know that the opposite sides of rectangles are equal. So since this base is 6, this little part of this base has to be 6 as well. And since we had a total of 12 inches for this base, and I've used 6 of those inches for this section, I have 6 inches left over to divide between for each of these lengths. And they have to be the same, right? Because these 2 markings tell me that these sides are congruent. So if I divide the remaining 6 inches up evenly, this has to be 3 and this has to be 3. Quick double check, is 3 plus 6 plus 3 12? Yes, it is. So now I have a right triangle with 2 of my side lengths known and 1 unknown, so I can use the Pythagorean theorem to figure out the missing side. Turns out that C is 12.4. So when I set up my perimeter, I have to add the 6 and the 12 from my bases, and then 12.4 twice, once for each of my congruent legs, and that gives me a total perimeter of 42.8 inches. Our last few examples turn it around. Instead of me asking for the area or the perimeter, I'm going to ask you for a different part of the shape. For example, if I want you to calculate the length of the base, given that this triangle has an area of 1,078 square feet, and that it's got this measurement right here of 44, well, what's the base? Remember that the base has to be perpendicular to the height. So 44 has to be the height because it's inside of the shape, and it's perpendicular to one of the sides. So this side over here on the left is the base, and I know you're probably not comfortable with that because that's not the side that the triangle is sitting on, but I can't say it enough. The base does not have to be the side that it sits on. The base is simply going to be the side that is perpendicular to the height. Additionally, you might have been uncomfortable with the fact that the height goes sideways instead of up and down. Same idea, the height does not have to be vertical. The height is just perpendicular to the base. All right, now that we've gotten that sorted out, that 44 is the height, and this side over here on the left is the base, that's what we're looking for, let's use our area formula. The area of a triangle is 1/2 base times height. And let's fill in what we know. The area, we're told, is 1078, and then the base is what I don't know, but the height is 44. So I can substitute in numbers into this formula like so. Then I can multiply the 1/2 and the 44, that gives me 22, and divide both sides by that 22 to get your final answer of 49 feet. That's how long this base has to be. On our next example, we're finding the length of one of the bases of this trapezoid, given that it has an area of 1,196 square yards, that one of its bases is 30, and that the height has to be 26. So I'm looking for base 1, and I know H, and I know B2, and I know A. So filling in my area formula, I can put 1196 in for A, 1/2 stays as 1/2, B1 I don't know, so I'm just going to leave it as B1, B2 was 30, and then H was 26. So all I did is I took my formula for the area of a trapezoid and I filled in the numbers that I knew. Now I'm going to multiply the 1/2 and the 26. I know it's kind of far apart from each other, but it's all just multiplication, so 1/2 of 26 is 13. Then I can divide both sides by 13, and that way I'm left with just B1 plus 30, which means all I have to do to solve is subtract 30 from both sides, so it turns out that base 1 is 62 yards. And our last example, we have a rhombus whose perimeter is 212 kilometers. And all that we're told is that it has one diagonal that measures 90 kilometers. All right, so what do I know about the perimeter of a rhombus? I know that it would have to be perimeter equals side plus side plus side plus side, because all 4 of these sides have to be the same thing, right? Because it's a rhombus. And I know that the perimeter is 212, so I can plug that in. Then combine my like terms to figure out that 212 equals 4s. Divide both sides by 4, and I find out that s, or each side length, has to be 53 kilometers. But I'm asked for the area, and the side length isn't what I need to calculate the area. What I need for area is the diagonals, and I only have one of them. I need to figure out the length of the vertical diagonal. Well, let's see if we can't use the good old Pythagorean theorem to figure it out. There's 4 right triangles in this diagram. I'm just going to pick one of them and solve it. So since I know that this whole diagonal is 90, I know that each part of that diagonal has to be half of that. And then I'll just call each of these parts of the diagonal that I'm missing, I'll call that x. And remember s, we know what s is 53. So I can set up my a squared plus b squared equals c squared like so. X squared plus 45 squared equals 53 squared. Crunch those numbers, and it turns out that x is 28. But we're not quite there yet, right? Because that's just what one part of that diagonal is. I need the whole diagonal. So diagonal 2 is 28 plus 28, or 56. Now I have all the information I need to calculate the area of this rhombus. The area of a rhombus is 1/2 times diagonal 1 times diagonal 2. We knew diagonal 1 all along, it was 90, and we figured out through quite a lengthy process that diagonal 2 is 56. So multiply those 3 numbers together, and I figure out that my area is 2,520 square kilometers.
And that's all you need to know about calculating the areas of triangles, rhombuses, and trapezoids. In our next video, we're going to discuss how to calculate the areas and perimeters of all of these types of figures when they've been graphed in the coordinate plane.